Hello, my name is Corey Maupin. I am the recycling specialist for Work in America. Today we're going to be talking about reclamation or full depth reclamation. In full depth reclamation, we're taking an asphalt layer and mixing it into the aggregate layer below it and trying not to get into any of the cement or the soils beneath. We'll talk about that more in the next slides. First thing we need to do in order to be a successful reclamation is come up with a plan. If we don't know what's under the materials or under the asphalt, we don't even know where to start, how deep to go, or what we're going to run into. So we need to have a plan or a mixed design. The design needs to be practical and obtainable, meaning that if we don't have a machine to do this, we need to take it off the list and we don't even need to talk about it. Or if we need 10 inches of material and we've only got 4, then we need to come up with a different solution. The design is the benchmark, meaning that we need to stick to the design or try to adhere to it as much as possible. And the construction should mimic the design, otherwise why have it? Important is that we have the appropriate equipment like I mentioned a second ago. If we don't have something capable of doing this, then we're going to have to either look at a different method or a different means to approach it. So here is an example of an FDR project or a future possible FDR project. Notice there's a lot of different asphalt problems going on here. We've got some patches, we've got some rutting, and we've also got some alligatoring and cracking. The mix design needs to include all of these problems. We need to have samples of the new asphalt from the patches. We need to have samples from the rutted spots and the alligatored spots to know what's underneath of them. That way, if we've got a base failure, we can correct it when we go through and do this and not pretend it didn't happen. Generally, full depth reclamation, we're going to cut through the asphalt overlay and into the base material. Like I said before, we do not want to pick up the base dirt. So the inherent soils underneath the materials could bring in a lot of fines and could bring in clays, moisture, other problems. So we want to try to leave those alone and leave them out of the mix. Typically, FDR is going to go from about 8 to 12 inches deep. We're going to take that asphalt and the aggregate below it and mix them into one homogeneous layer. Different types of applications of FDR. So we've got reclamation with cement, reclamation with emulsion, and then reclamation with foam bitumen. We're going to talk a little bit about these products, but we're going to primarily focus on the cement. So this is an example of weather restrictions, specifically for VDOT area. This restrictions or advisements go for generally most across the country. We want to have greater than 40 degrees in the pavement and the ambient. We want the ambient to be rising and no heavy rain in the forecast. We don't want to open up this road to a gravel or grind it into a gravel and then have a huge downpour wash all our fines out and create a big lake for us. All right, so here's a rundown of the process of full depth reclamation. We're going to close the working area to traffic, downsize all the existing materials, or grind up the asphalt into smaller granules, addition of binders or additives if needed in the design, and then mixing all the materials uniformly. After all of that, we're going to start compacting the mixed materials, and then a final shaping of the mixed materials using a blade or other kind of structure to get the crown of our road back and whatever areas that need to be smoothed and fixed. Finally, after the shaping, the final shaping, we're going to compact anything that was loosened during that, apply a fog seal, and then open it to traffic. Very important here, some of these materials we're going to use have a curing period. So cement, for example, we generally want to stay off of a cement-treated base for at least 3 or 4 days. Emulsions are typically somewhere around 3 days. Foamed asphalt is probably the only exception that we're trying to get on it as quickly as possible. And then finally, we have the installation of a wearing course. Here we have a short animation showing the FDR or full depth reclamation process. First, we have a Stroy master spreading a layer of cement. This is a crucial point for the success of the complete job. The layer of cement needs to be spread evenly and according to the mix design. We'll talk in the next few slides about some of the common problems with the spreading process. Next, we have a working reclaimer connected to a water truck. The water truck is supplying the mixer with a continuous supply of water to inject into the material in order to achieve proper moisture content. The water is injected directly into the mixing chamber to achieve optimum moisture through the entire thickness of the layer, according to the requirements of the mix design. Injection bar is adjustable through 8 individually controlled nozzles to achieve half passes and partial passes. Next, a hom roller of adequate size to achieve full density through the entire layer. And after initial compaction, we grade the road to achieve proper slope and smooth ride. Then a double drum roller to recompact what the blade disturbed, and finally a rubber tired roller. All right, the first thing we've got is cement spreading. In this video, we've got a nice demonstration of how not to spread cement. There is absolutely no control coming out of the back of the truck. We have no idea how much cement we're spreading and where we're putting it. So in the very beginning, there was a large pile. And then as the driver pulls the truck forward, there's no spreading dependent on the movement of the truck. So we get a large, thick, heavy pile. And then you notice about 10 feet in front of it, you can still see dirt. It was very thin spreading. And then we go thick, thin, thick, all over the place. We have no control of this at all. As soon as he stops, we get a big pile. What this ends up doing is making a very rigid cement, concrete-like area in those deep spots. And then in the other areas, it's very thin and not enough strength. So we end up creating basically a boulder in the road and then sand next to it. So the heavy cementitious areas end up being a very solid rock, while the rest of it is very lightweight and still underrated capacity for the road. And this kind of shows that same thing. We've had almost 18 inches of depth into one spot. And between the starting and stopping, like I said, there's no control in the metering from the cement truck. So heavy spots, light spots, we get over strength and under strength the whole way down the road and no way to control it. Here are some of the different methods for spreading cement that we've seen around the world. In the upper left-hand corner, very similar to the truck spread that you saw before, except they were using a box to inject into and try to spread to help control the uniformity of it. This would help eliminate some of the surging, but as you can see, the box is not very big. It's still going to have the very similar problems. Bottom left, basically they were spreading using a loader and a laborer on a broom trying to knock down the piles. But same as before, you really don't know how much you've spread. The only way is basically you could take a shop vac and vacuum up a certain area to determine the weight, but that's going to be very inaccurate. Top right was some kind of machine made by a customer, very similar to the box drag. It was a little bit better. It had a control gate at the back to help determine what amount was laid down. And bottom right, a lot of the third world countries we see using this method, they have trouble getting cement, so they just spread out bags. They walk off the bags and know each bags should cover a certain linear footage on the road. So they just spread them out and either run over them directly or break them open and spread a little bit. All right, as we talked about a little bit, getting too much cement is just as big of a problem as too little. If you get too much cement, you create a concrete slab, which is very rigid. And if that rigid concrete slab is on a poor base or a poor load-bearing base, then you'll get cracks. Typically, you see the cracks starting at the top and propagating down, larger at the surface. You also get cracks where the cement is drying out and shrinking. So you get a little bit of the cracking in the top photo. But one way or another, the layer is more rigid than you desired. So it's going to end up crumbling and causing problems down the road. On the other side, lower than design, you don't have the cement, so you don't have the load-bearing capacity that was designed into the mat. And as a result, it will not hold the traffic. You get rutting, potholing, and other problems. The biggest issue with both of these is you'll finish the road and you won't see any problems until a year or two down the road. Then all these items will show up as a problem. Here you see the VDOT recommendation for full depth reclamation spreading of binders. As you can see here, 0.2 percentage points of the mix design. So as we saw in the previous slides, too much or too little can cause a lot of problems later down the road that are not always visible. So because of this, VDOT regulates that application spread rate to be very close to tolerance. So a 5% design can only go 4.8 to maximum 5.2. Here are some basic execution points or best practices for cement. Keep the distance of the additive spread minimal. So don't run out and dump an entire load in front of you. You want to keep it close to the recycling train in case of rain or mechanical breakdowns, other problems. Uniform spreading of the additives, and also yields of the loads. So first load of the day or almost every load of the day, you want to lay out how far the tanker should go and try to stick to that. The next subject is water. So same thing. If we throw too much water or too little, as in these two slides showing, we can cause just as much problems as too much or too little binder. Here's a good example of uncontrolled water. So the contractors come through, spread water out of the back of a water truck just by spraying the nozzles. And he's only wetting the surface of the layer, first of all. So half of his water is running off in the ditch before it's ever used in the layer to get the moisture content right. The other problem we see here is not as just the water running across into the other lane, he's actually pushing some of the cement over there. So now we're low yields on cement, low yields on water. We've got a weak base structure as well as a dry base structure, so we're not going to get density. And here's the specification from the VDOT for moisture contents. Moisture contents have to be plus or minus 2% from the optimum as determined by the design. And the reason we want to stick close to this optimum design, we don't really want to go over it because we'll start flooding the area and causing floating of materials. But we need to stay very close to it in order to get our optimum compaction or optimum density as determined in the mix design. And again, we have a shot of the Wirtgen mixing drum injecting moisture directly into the mixing chamber. As shown in some of the previous slides, with the water being sprayed on the surface, that only wets the surface. We don't get our optimum moisture through the complete mixture of the mat. So we end up with dry on the bottom, wet on top, bad compaction, bad density. Here is the display that the operator sees to control the water system and bitumen system in the mixer from working. We've got 8 spray nozzles across the water, 16 injectors total. They're paired together. They're microprocessor controlled, and we get a precise accuracy for what the operator needs. If he wants to adjust higher percentage, he just clicks on the knob and turns it up. He can also turn on and off nozzles for half passes, which we'll talk about here in the next slides. Here's a typical connection of the recycler pushing a water truck. This gives him enough capacity for water, depending on his application rate, to get down the road a couple thousand feet or at least a couple hundred feet, and he's not having to constantly stop and redo water. A good note about this is when you are connected to a truck and using the push bars and pushing a water truck like this, be very mindful of dropping the water tank and disconnecting. Your hose itself is about 10 foot long, will hold 2 or 3 gallons of water. And if you just drop it right in the middle of the recycled mat or pulverized mat, then you could potentially flood that area, and we've lost all the accuracy that we have. So when disconnecting, try to throw the hose off to the side of the road in the ditch and let it drain there. Here's one last slide on water. This one's about as comical as anything else, but basically the idea is to talk about leaks. So there we've got 2 different leaks. They're not that big of an issue, but the further we go up this train, the more leaks we run into. The more leaks we have, the more water we're dropping. The more we're dropping, this one's not as big of a deal because it's on an asphalt surface, so most of it's going to just run off into the ditch. But if this had been a gravel or pre-pulverized job, then we would be putting all of this moisture back into that road bed. So that kind of messes up our moisture contents that we've been so critical about and trying to gain. Our compaction is lost because we're oversaturating, and it just makes it very difficult to monitor and control that optimum moisture content. All right, our typical job, because we only have an 8-foot wide mixer and a 12-foot wide road, we're going to take the centerline pass, and then we're going to come back in the next step, and our second pass will be on the edge of the lane. Because of this, our second pass is going to have half of its spray bar turned off. So our nozzles in that display are used to turn half the nozzles off on the recycling side that's already been done. Maybe we leave 1 or 2 on just to keep moisture in that existing mat if it's been a while since we've done it, but it gives the operator the control. The equipment in the FDR train is a cement spreader, just as before, water truck, and the transport for the bitumen. Then our recycler, pad foot roller, our blade to get our road profile, and then a double drum vibratory roller to basically fix the what the blade disturbed and recompact it. And then we've got a pneumatic roller. Our pneumatic roller, as I said before, we're trying to create a slurry or a slush on top of the mat. What this does is we put a little bit extra water down after the double drum roller. We try to soak the surface and then bring some of the fines up to the top with the pneumatic roller, using it to knead the surface back and forth and create a healed, somewhat smooth surface for the fog seal to stick to. This can be done with the cement process. Sometimes it is, sometimes it's not. It depends on what they're going to put back on top of it, whether it's going to, how long it's going to be left. In this slide, we have the truck connections from the machine to the hot oil tanker for the use of bitumen foam. If it's an emulsion job, the setup will be nearly identical. The biggest difference with foam is we're dealing with a dangerous hot material. Asphalt needs to be 320 degrees Fahrenheit or higher when it gets to the job or when it's in use. Typically that means it gets to the job, it has to be 330 or better. So we need to take a lot of precautions about hooking up to connections of the machine and the tanker, as well as the hoses when we're doing this process. As you can see here, the operators or the people connecting the truck to the machine have to have face mask shields, proper PPE for dealing with this. We also have to have hot rated hoses, gaskets, and connections. So it's very important to remember all this well ahead of the process. Here we have a view of the mixing rotor under the Wirtgen WR. The mixing rotor is a vital, important part to all of this design. The mixing rotor and the teeth on it are going to control our gradation. So the number of teeth, how easy they are to change, all of this is going to start coming into focus because of the mixing drum. In order to get our gradation, we need to have the right rotor speed, so we can adjust the rotor speed anywhere from 90 to 200 RPM. We can close and open the front and rear doors to try to help this gradation process, and we can speed up or slow down the machine. Here's another shot of the VDOT specifications. So we have to be able to get 100% passing on a 2-inch sieve. So gradation becomes a very important process. We have to pay attention to it. Like I said, use the tools we have to control it. Here are two examples of good and bad gradation. On the left side, as you can see, we're well below our 2-inch minus. Our moisture looks good. We've got nice, clean tracks from the tires, the rear tires making imprints. They're clean edges. They're not falling over because they're too dry. And on the right side, we've got loose gradation, or loose, large gradation, low moisture level. You can see the material's falling down the hill because it doesn't have any moisture to keep it up. All right, when we're recycling, there's a few things that we need to check, a few things that we need to constantly check. So moisture contacts, if we're using emulsion or foam bitumen, we need to keep an eye on how the foam is doing. Emulsion is basically, we're just making sure our yields come out right on our truck. Also checking the gradation, foam quality, and as I said before, yields. Here's an example of a few checks that we're doing for moisture. So we're going to grab a ball of material in the top left corner. We're going to squeeze it as tight as we can. And basically what we want is a nice tight ball that's still intact. If we try to split the ball or separate two pieces, as you can see in the lower left, it splits cleanly without a lot of crumbs. And then you can see again in the lower right, we've got nice clean tire imprints. The edges are very clean. They're not falling down or sloughing because of low moisture. We have similar checks for foamed asphalt. Basically we're going to grab a ball just like we did with the moisture checks. Except in this case, when we get through the moisture checks, we throw the ball down and we're looking for all these little tiny dots in the right-hand side picture. All these tiny dots suggest that the bitumen or the foamed asphalt is dispersing very finely through the mat. We're looking for stringers as well. We don't want to see any big chunks, gooey asphalt, or long strings of it. This is a picture of what foamed asphalt looks like coming out of the machine. There's a test port in the front or the side of the machine in order to check this. And Typically, asphalt has to expand several times its volume, and the best that I've seen of it is when this goes from a glossy color to a dull color, like shaving cream. That is the best you can get. So ideally, you want this to look like black shaving cream coming out of the bucket. Lastly, we can start talking about rolling. 15 to 20 ton pad foot. As we said, depending on the depth of the mat we're recycling, typically we're in 8 to 12 inches of material, so we're going to need something heavy and preferably pad footed. If we don't get a heavy enough roller or a pad foot particularly, we start over compacting the top layer and the bottom layers of the mat are not fully compacted. So our density numbers show off a little bit because it's averaging over the full depth. And eventually the road will settle and fail in those spots. So as it says here, it's vital for the project's success. The greater the depth, the more vital it is. There we have our blade. Doesn't really matter which blade. All we're trying to do is get our final gradation and smoothness of the road. We're also looking for the blade to get the smoothness and the slope of the road and then get off. We don't need to be playing with this material all day long. We're going to dry it out and cause ourselves more problems than we create or than we gain. So as you can see there, moisture must be kept in material during this process. Sometimes we have to run an extra water truck down through a job after grading or during blading to get a little moisture back in there if it's a really hot day. Our double drum and our rubber tire after blading. Again, our double drum is kind of recompacting all the material the blade scraped up. Usually they're working together with the blade to keep all that kneaded down and compacted, again with the correct moisture. And then our pneumatic, we're going to roll and knead the material to get our smooth finish. Here's a job example of a good finished road. You can see lots of smooth areas. There is a little bit of grain on the left side and some down the middle. But overall, the job is very smooth, very tight and compacted, not a lot of loose material. You can also see a little bit of the blade dimples, but for the most part, the blade operator is cut down deep enough to get the dimples out. That's very important. We'll see that in the next slide. And then they slush rolled this, as we talked about before, and basically the slushing brings some fines up and makes the surface knead into a nice tight mat. After finish rolling, we fog seal. The purpose of the fog seal is to protect the road from water intrusion while it cures. And then we open it up to traffic. So afterwards, a good finish holds the water out, seals the surface. As you can see, this was a very hard road. The operator or the contractor had an issue with a bump, so he tried to get a grader on it, and you can see the grader really fought this material and had a hard time scraping it. And after the good finish, we got good results. This was just a simple chip seal placed on the road, and the resulting road holds up for a long time. Now the pour finish. So you can see lots of dimple marks from the pad foot roller. The blade operator did not cut deep enough to get the pads out, and now what you can see is the dimples hold loose material. So the smooth drum roller goes along and rides along the edges of the pads or the center of the drum pads and cannot get down into the holes to get the material compacted. So then the material stays loose. They didn't slush roll it, and all this loose material just continues to lay on top of the surface and ravel and cause problems down the road. Preparation. The biggest thing you can do to make a successful job is think about it before the job happens. So 1 to 2 weeks prior, talk with the contractor, talk with the government agency, whoever owns the road, talk about who's going to test it, who's going to check it, what's going to be done. All of these things need to be laid out long before the equipment hits the job. The better you plan, the better you succeed.